Hello everyone, welcome to you. And this is video lecture series, and I'm covering unit number 3. The major topic of this unit is IC engine. Okay, so this is lecture number 2. Okay, so introductory part is already over, so it is available in YouTube, so you can watch that lecture. And in continuation of previous lecture, now I'm going to start this lecture. So let's see. First, we already know what is IC engine, and once again you can see what are the construction features of IC engine. So this is a cross-sectional view of IC engine in which we have many parts. Like if you can see here, from this you just say this is a, you can say this is a cylinder. Is it right? This is a cylinder and this is a piston. Is it right? And this piston can reciprocate inside the cylinder. And along with this, this rod is nothing but this is called as connecting rod, and this connecting rod and this piston both are connected with this gudgeon pin, and here we have hinge support so that this rod can move here and here like this in an angular path. Is it right? And now after that, this connecting rod, we have this link is called as crank, and this crank is actually having complete rotatory motion in a 360 degree. And of course again here we have a hinge joint and here we have a hinge joint, so that relative motion between the connecting rod and the crank takes place. And similarly from the crank shaft, this is a crank, this is a crank, and this part is called as crank shaft. Is it right? And of course this crank shaft is connected with the prime mover of the vehicle. Is it right? Which runs the vehicle. Okay, so these are the important part of this. And of course this is a once again you can say this is a crank shaft, this is a crank, this is a connecting rod, this is a piston, and of course this is a cylinder. Is it right? And apart from these parts, you can say this covering is nothing but, actually this is called as crank casing. Is it right? This covering is nothing but this is called crank casing. Is it right? And in this crank casing basically we have a lubricant oil. Is it right? Here we have a engine oil, you can say, correct, which lubricates this crank and connecting rod and crankshaft. Okay, and after that you can see here we have two valves. This is inlet valve and this is outlet valve. Is it out? Is it right? This is inlet valve and this is outlet valve, and of course this is a inlet manifold. Is it right? This is a inlet manifold, means it is just opening from which air, either air or a air fuel mixture can enter into the cylinder. And this is another manifold which is called as exhaust manifold, and its purpose is to remove all the combustible product which is placed inside the cylinder. Is it right? After the expansion, correct. So here we have two valves and two manifolds. Is it right? Two valves and two manifolds, one manifold for the inlet and another manifold for the exhaust, correct. So these are the important parts of this IC engine, and of course apart from this many more parts are also there. Is it right? So let's see, sometimes in the exam if I see, then they simply ask construct IC engine and explain the component of important components of IC engine. Is it right? Then how you need to draw this figure. Actually this is a cross-sectional view which is directly I have taken from the textbook, but you need to draw. So you just see here in this slide I am going to tell you how to draw this figure. Is it right? Then you need to draw basic features of the IC engine. So first you need to draw a you can say this is a piston, sorry, a cylinder, not piston, this is a cylinder. Is it right? And inside this cylinder we have a piston. Even you can use a multicolor pen for drawing this figure, or you can draw this figure with the help of pencil in your exam. So this is a piston. Is it right? And of course this piston is connected with the crank, sorry, connecting rod. This is a connecting rod. Is it right? And this connecting rod is further connected with the crank. Is it right? And this is a crankshaft. Is it right? And obviously here we have an inlet valve, so you can just represent this inlet valve like this. This is a sorry, this is an inlet valve and this is a exhaust valve. And of course for this for intake, Here we have a manifolds. This is an inlet manifold. Is it right? And similarly, this is an exit manifold. Is it right? Inlet manifold and exit manifold. Correct? And if this is a spark ignition engine, then of course here we have a spark plug. And even if it is a compression ignition engine, or you can say diesel engine, then it will be called as a fuel pump. Is it right? So this is a spark plug. You can see here in this figure, this one is called as a spark plug. Is it right? And of course, if you write their nomenclature, then this is an inlet manifold. Is it right? This is exhaust manifold. Correct? This is a cylinder. This is a piston, and this is a connecting rod. The connecting rod. This is a crank, and this is a crankshaft. Is it right? And it is not necessary to make a crank casing. Is it right? Because this figure indicates all the important parts which is provided in the IC engine. Is it right? So this is either a spark plug, and if it is a diesel engine, then instead of spark plug we have a fuel pump. Is it right? Correct? So these are the important parts of IC engine. Are you getting my point? So like this, you can draw this figure and represent all the important part. And of course, this is a valves. Okay. So this is inlet valve in short, if I say, and similarly, this is a exhaust valve. It can be represented by EV. So this is an inlet valve which is represented by IV, and exhaust valve which is represented by EV. Correct. So these are the important, you can say, component of IC engine. Are you getting my point? Let me shift this figure slightly towards right. Okay, so now it is clearly visible. So like this you can draw the figures. So once again, first you need to draw this cylinder, and after that this piston, then connecting rod, then crank, then crankshaft, then of course this inlet valve, exhaust valve, inlet manifold, exhaust manifold, and then this is a spark plug. Okay, so if you represent this information in your exam, then it is enough. Is it right? And next you can see the nomenclature. Is it right? Nomenclature, this is again very important because I need to represent uh, what are the important terminologies of IC engine, because while discussion we need those terminologies. So you can see here again, you can see multiple times I will draw this rectangle box. This is nothing but this is called cylinder, and of course inside the cylinder we have piston. This is a piston. Is it right? And here I'm not talking about the shape and size of the piston. Is it right? So simply you can say this is a piston. Correct? So if your piston, suppose if your piston is positioned and somewhere here, is it right? Let me show you. Okay, somewhere here. Is it right? Like this. Either it is situated somewhere here, or you can say it is situated somewhere here. In the another figure you can see. Okay. Hmm. Correct. So in this situation, in this position actually, if you see the connecting rod, then it is simply looking like this. This connecting rod and this crank both are collinear. Is it right? Both are aligned to each other. Is it right? And similarly, and even if I draw this crank with a different color, so this is crank. So you can see both are in collinear. Is it right? But in case of this position, if I draw, okay, so now you can see. Now this your connecting rod is somewhat, it is located like this, and similarly, and the crank is located like this. Is it right? So you can see both overlap to each other. Are you getting this? Both overlap to each other. And you can say this is a cousin pin, and this is a contact point of crank and connecting rod, and this is a crankshaft. Is it right? So it is located like this, correct? So this extreme position of piston inside the cylinder, this is extreme position. Is it right? Extreme top position means this is the furthest point. If I see from here, correct? So this is my reference. This is my reference. According to this reference, if I say, then this is a furthest point, furthest position of this piston. Is it right? This is a piston and this is a cylinder. You must aware with this, okay? So this is a furthest point, and simply if I see, then can I say here, this is the, if I say the top plane of the piston, then can I say this is the bottommost position? Yes or no? So can I say this is the nearest position? This is the nearest position from the crankshaft? Yes or no? This is the nearest position, and this is the furthest position. Correct? In this case, connecting rod and crank both are aligned together in a linear manner. Yes or no? This is called collinear. And again here we have the linear, but crank and connecting rod both are overlap to each other. Is it right? So this is the nearest position. Okay. So this furthest position of the piston is called as top dead center. Is it right? This is called top dead center. Similarly, this nearest position of this piston is called as bottom dead center. Is it right? Why it is called bottom? Why it is called dead center? Why it is called dead center? So the answer is, since this is the extreme position of the piston, means this piston cannot move away from this line. Above this line, this piston cannot move. That's why this is called dead point. And similarly, below this piston cannot move. So that's why this is called. This is also called as dead point. So since at this position the piston is nearest to the crank, nearest to the crankshaft, this is crankshaft, and this is also a crankshaft, and here this is the furthest from the crankshaft. So furthest from the crankshaft, this is called furthest, means this piston is positioned at a maximum height. Yes or no? Correct. And this is nearest, so furthest point is called dead center, top dead center, and nearest is called as bottom dead center. Is it right? Now the question is why we provide this space. So this space is very essential. Why? If you are not providing, then this piston directly hits the uh, top surface of the cylinder, then it damages the cylinder. Yes or no? This is one reason. Another reason, here we also have valves. Is it right? Here we also have inlet and outlet valves. So for this, we need some space. So that's why we will restrict this piston to move up to this position only. Is it right? That's why we will provide this gap. Is it right? So from this you can understand what is the top dead center and what is the bottom dead center. And similarly, if I draw its cross-sectional view of the piston cylinder, and if I talk about the cylinder especially, so it is looking like this. Is it right? It is looking like this, and this is called as bore diameter of the cylinder. This diameter is nothing but this is called D is called as bore diameter. Bore diameter, is it right, of cylinder, correct? And if I see here again, in between this, in between the top dead center and the bottom dead center, the piston can move up to this linear area, yes or no? So this is called as stroke length. It is called as stroke length. This capital L is nothing but this is called stroke length. Is it right? This is called stroke length. Are you getting this? And the whatever volume we have inside this piston in between top dead center and bottom dead center, then this volume is nothing but this volume is called as swept volume. Is it right? The volume inside the cylinder between the top dead center and bottom dead center. So this is nothing but this is called Vs. This is called swept volume. Is it right? Swept volume. Are you getting my point? This is called swept volume. So what is swept volume? So if I write swept volume, then simply we need to find out the volume of the cylinder. This is a cylindrical space. So simply can I say this is a pi by 4 times of bore diameter pi by 4 d square. This is the cross sectional area. And if you multiply with the stroke length, then you will get the swept volume. So like this you can find out the swept volume, and whatever volume here we have above the top dead center, so this is called clearance volume, Vc is nothing but this is called clearance volume. Is it right? Are you getting my point? This is called clearance volume. This is called clearance volume, correct? Vs is a swept volume, Vc is a clearance volume. Are you getting my point? So simply again, if I represent this swept volume and clearance volume, then simply you can say here, if we have this is a piston, sorry, cylinder, correct? This is a cylinder, and if your piston is positioned somewhere here, so whatever volume we have inside this cylinder means this one. So this is called as clearance volume. Similarly, similarly, if your piston is positioned somewhere here at the bottom dead center, correct? So obviously this is called total volume. Is it right? This is called as, this is called as total volume, which is represented by, let's say, V. Is it right? This is total volume, or you can say this is V1, correct? So this V1 is nothing but this is Vc plus Vs, and which one is Vs? So simply if I draw the reference line from here and one reference line from here, so this volume is basically, this is called swept volume. So this and sorry and this volume is called Vc. So Vs plus Vc, their sum is equal to total volume V1. Is it right? So don't be confused with this. So Vc is a clearance volume, Vs is a swept volume, and V1 is a total volume. Total volume. So generally, if you see your automobile like a bike or a car, then we always discuss the engine size is 1000 cc Or if I talk about the bike, then you can say this is a 200 cc, 350 cc, yes or no? So what do you mean by 350 cc? 350 cc. The meaning of 350 cc, or you can say 1000 cc, then this cc is nothing but this represent cubic centimeter. Is it right? Cubic centimeter. And basically this cubic centimeter, this 350 cubic centimeter represents the cylinder volume. Is it right? Cylinder volume. Now the question is which cylinder volume, because here we have Vs, here we have Vc, here we have total volume. Then we always represent only swept volume. Then engine capacity, this is also called as engine capacity. Engine capacity, is it right? So engine capacity is always represented by the swept volume, remember this. So what is the meaning of 350 cc engine? 350 cc engine tells us the volume capacity of our engine is 300 cubic centimeter, is it right? So from this you can understand what is the capacity of the engine. So this is the basic terminology of IC engine, and you can see all the details are given here. So if you're interested, then you can read it. So once again you can see this is the top dead center, this is the bottom dead center, is it right? And cylinder bore, then piston area is nothing but this is cross section area of the piston. Stroke length means it is the length up to it is the length which is covered by the piston between the top dead center and the bottom dead center. Similarly, you can see the stroke to bore ratio, that is L by D ratio. Dead center, in which we have top dead center and bottom dead center. You already know this is top dead center, this is bottom dead center, and the length between them is called as stroke length, and this diameter is called as bore diameter. So in detail, if you're interested, then you can read it. I will provide this notes, and this notes is available in my Telegram channel. So you just join, and the link of Telegram channel is available in the description of the this video. Okay. So once again, this thing is again described here. You can say, and from this figure, this circle actually represents crank, and this ring, this represents rectangular section, represents connecting rod. So you can see this is the region where both are overlapped, and here there is no overlapping, is that right? Which I already told you in the previous slide. So for the university exam purpose, if they ask what is top dead center, then simply say it is a dead center when the piston is furthest from the crankshaft. Remember, this crankshaft, this here we have a crankshaft exactly, if I see correct. So this is the location, this is the reference point. So from this reference point, the furthest position of piston is top dead center. And similarly, and of course, we always measure from this, and similarly here we measure from this, correct? So nearest position is called as bottom dead center, is it right? And of course you can say this is a this is called clearance volume, which is already written here. And this is a you can say this swept volume is also called as displacement volume, is it right? So don't be confused with this. This is a swept volume. So obviously, what is swept volume? So this is a volume between top dead center and bottom dead center. Is it right? Is it right? So you can say this is a TDC and this is a BDC. So volume between the top dead center and the bottom dead center, this is called swept volume, or you can say displacement volume. Is it right? And actually this displacement volume produces the work input. Okay. And another term we have, that is a compression ratio. Then what is compression ratio? Then you can see throughout the piston, here we have one volume. This is called as a V1 volume, and this clearance volume is called V2 volume. So let's I'm just showing you here. So you can see here we need here compression ratio, is it right? Compression ratio. This is again very important terminology for IC engine, especially when you study air standard efficiency of IC engine. Okay, and it is represented by, let's say, RK. This is a compression ratio. So if you have a piston cylinder arrangement, horizontal arrangement, is it right? And with reference to this, if I draw the PV diagram, pressure versus volume diagram, is it right? This is a PV diagram, correct? Here we have pressure and here we have volume. And let's suppose this is a dead center, this is a dead center, and this is another dead center. So this is a TDC and this is called BDC. And here we have a crankshaft, is it right? So, so you can see here, whenever you see horizontal engine, then this TDC is named as, this is called outer dead center. That is called ODC. And similarly, this BDC is further named as inner dead center. Is it right? So ODC is a outer dead center and IDC is a inner dead center. Is it right? So inner ODC, TDC both are same, but yes, if you have vertical engine, then we use TDC, BDC, and if you have horizontal engine, then we use ODC and IDC. Is that right? So of course, if your piston is positioned somewhere here, at this position, this is point 1. So at this sense, you can see here we have large volume. Then of course, with the large volume, the volume will be less. So whatever volume here we have this, so this is called V1 volume. Is it right? And at this situation, the pressure will be P1. Is it right? This is P1 pressure and volume is V1. Is it right? But when your piston reaches from BDC to TDC, then this volume is nothing but this is called V2 volume. And of course here, since the whole gas is filled at this small area, therefore pressure will be increases. Yes or no? So when the pressure increases, then of course correspondingly you can see the volume decreases. So this is called V2. Is it right? And corresponding to this point, here we have P2 pressure. And remember, P2 is always greater than P1. Is it right? P2 is always greater than P1 and V1 is always greater than V2. And you can see, can I say here, this V2 volume is nothing but this is called clearance volume. Is it right? And of course, V1 volume is nothing but this is Vs plus Vc. Is it right? And V2 is nothing but this is Vc. Correct? So after knowing these information, so can I say here the compression ratio is nothing but it is the ratio of total volume of the total volume of the cylinder, that is V1 divided by V2. Is it right? So this ratio means volume at this point means when your piston is positioned at BDC or inner dead center, then this is called V1. And when your piston is positioned from at the TDC or you can say ODC, then this is called V2. Is it right? So this ratio V1 by V2 is called as compression ratio, and this V1 can also be written as this is Vs plus Vc, and instead of V2 we can write Vc. So this compression ratio can also represented by this ratio 1 plus Vs plus Vc. Is it right? Means compression ratio is always greater than 1. Is it right? From this relation you can say the compression ratio is always greater than 1, and generally it is taken around 8 to 10 for petrol engine and around 16 to 20 for diesel engine. Is it right? So what is compression ratio? So simply you can define compression ratio is nothing but it is the ratio, you can say this definition is written here, the ratio of maximum volume formed in the cylinder to the minimum volume, that is also called as clearance volume. So maximum volume that is V1 over minimum volume that is V2, and it can also be written as Vs plus Vc over Vc. Is it right? And it can also be written as 1 plus Vs by Vc. So either it can be represented like this, or it can be represented like this, or it can be represented like this. So this is called compression ratio. So I hope you will understand what is compression ratio. Is it right? And rest information you can see here, which I already explained you, that is a swept volume. So what is swept volume? The nominal volume swept by the working piston means when your piston moves from TDC to VDC, then how much volume is displaced. So this volume between TDC to BDC, TDC to BDC, this displaced volume is called as swept volume. Is it right? And cubic capacity, and you can say swept volume is represented by this formula, pi by 4 d square into L, where d is the bore diameter of the cylinder and L is the stroke length. Is that right? And cubic capacity of the engine, if I say, then if you have single cylinder engine, then it will be a simply Vs. But if you have multi-cylinder engine, means if you have k cylinders in your IC engine, like in a car basically we use 4-cylinder engine, then the total volume or cubic capacity of engine is nothing but it can be simply written as Vs into 4 if you have 4-cylinder engine. Is it right? If you have 4-cylinder engine, then if you want to write their cubic capacity, then simply you just multiply the swept volume into number of cylinder. K here, K represent number of cylinder. So simply it can be written as pi by 4 into d square into L into 4. So like this you can find out the cubic capacity of the engine. Is it right? And clearance volume, the nominal volume of the combustible chamber above the piston or above the top dead center is called as clearance volume. And this is the compression ratio. Is it right? Total volume upon compression ratio. So every definition is written here. I explained you what are the terminologies. Is it right? Correct. Next, generally in the university exam, they ask what is the classification of IC engine. Write down the classification of IC engine. So IC engine is classified in many ways. According to the cycle of operation, if I say, then IC engine is divided into two categories, that is 2-stroke engine and 4-stroke engine. Is it right? And what is stroke actually? See, if you have if you have a cylinder and this is a piston, is it right? So and it is connected with the crankshaft, let's say like this. Is it right? So by one complete revolution of the crankshaft, is it right? One revolution of crankshaft will be considered as one you can say, in this basically the piston can move from BDC to TDC. Is it right? BDC to TDC means in one half revolution, by 180-degree revolution of the crankshaft, the piston can move from BDC to TDC. In another half rotation, the piston can again move from TDC to BDC. Is it right? So in one complete revolution of the crankshaft, we will get here two reciprocating motion of the piston from bottom to top and top to bottom. So it will be for 4-stroke engine, it will be considered as two stroke, and is it right? And this is called in one revolution of the crankshaft, simply we will get here 2 strokes. Is it right? Means your piston can move from BDC to TDC. This is one stroke, and from TDC to BDC this is another stroke. Is it right? Correct. So this is 2 stroke. It means for 4-stroke engine we need at least 2 revolution of the crankshaft. Is it right? In 4-stroke engine we need 2 revolution of crankshaft. Yes or no? And similarly for 2-stroke engine we need only 1 revolution of crankshaft. Are you getting my point? See here, in one revolution of the crankshaft, basically the piston can reciprocate from either from BDC to TDC and TDC to BDC, or from TDC to BDC and BDC to TDC, whatever you consider. Is it right? So in it means in one revolution of the crankshaft we will have 2 strokes. Is it right? So in 2-stroke cycle engine, basically we have one revolution of the crankshaft, and in 4-stroke engine we have 2 revolution of the crankshaft. And what is the meaning of this one revolution? Actually in one revolution of the crankshaft in 2-stroke engine we will get power stroke. Is it right? And in 4-stroke engine basically in 2 revolution of the crankshaft we will get power stroke, one power stroke. Is it right? one power stroke. Correct? And next, according to the cycle of combustion, if I say, then IC engine, it may be a auto cycle engine, which is also called as combustion at constant volume, and diesel engine means combustion at constant pressure. And this will I will explain in the later on class. Okay. Next, according to the fuel employed, then obviously we have gasoline, gas engine, oil engine, petrol engine, kerosene engine, alcohol, ethanol, methyl engine, LPG engine, dual fuel or multi-fuel engine, and even hydrogen fuel engines. So we have, according to fuel, we have multiple types of engines. Is it right? So the first classification on the basis of cycle of operation, 2 stroke, 4 stroke, according to the cycle of combustion, either constant volume combustion or constant pressure combustion. Is it right? And according to the method of ignition, if I say the spark ignition engine, so basically this is petrol engine, and in this petrol engine we have spark plug. Is it right? Here we have spark plug. And in compression ignition engine, this is called diesel engine. Diesel engine. Is it right? And in this, basically, we have fuel pump. In this, we have fuel pump. Okay. And next, according to the method of cooling, then of course it may be air cooled engine or water cooled engine. Is it right? So if I talk about the bikes, then generally all the bikes whose capacity is less than 350 or up to 350, generally we make air cooled engine. And for this, you have seen in the your engine, the fins are provided like this. Is it right? Like this. Okay. But in water cooled engine, we have a water jacket through which we can pass the water to cool down the engine. So in the generally in the cars or bus or truck, we use water cooled engine. Means in the heavy engines, is it right? Even in the bike, if the engine size is very big, around 1000 cc, 2000 cc, then definitely we need to use water cooled engine. Okay. And next, according to the number of cylinders, either we have single cylinder engine or multi cylinder engine. So this is the detailed classification of IC engine. Correct? So in this lecture I covered what is the construction feature of the IC engine, what are the important components of IC engine, what is the nomenclature of IC engine, how to define the terminologies of IC engine, then classification of the IC engine. Is it right? So in the next class, again, I will explain you that is working principle of four-stroke engine. So now I'm going to end this session. Thank you and good day to all of you guys.